What happens in the winding facility? Thanks to this synchronized winding line, we will bend 750 meter long lengths of conductor into a double spiral trajectory to form what is known as a double pancake. It is D-shaped and measures roughly 13 meters long by 9 meters wide. The conductor itself is what is known as cable and conduit. It's formed from a cable of roughly 1400 niobium tin and copper strands, which are fitted inside a stainless steel conduit of about 45 millimeters diameter. An important aspect is that the superconducting properties of the niobium tin strands are obtained only after heat treatment at up to 650 degrees centigrade. What's challenging about the work being undertaken? Well, above all else, extreme levels of accuracy are required. For instance, we need to control the length of the conductor during bending to an accuracy of around about 0.05 of a millimeter per meter. To do this, laser systems are used to determine the correct length of the conductor for each turn. As its length changes during bending, we measure the conductor both before and after in order to compensate for this and to achieve the correct length in the end. In addition, there is a further change of length as a result of the heat treatment process, which we must also take into account. The requirement for high accuracy is linked to the fact that after the conductor is heat treated, it will need to be inserted into the grooves of the radial plate. The radial plate is similarly D-shaped. It's made of stainless steel and it has grooves on both sides to match the trajectory of the conductor. In order to fit the conductor into the grooves, we need to have both the conductor and groove trajectories to match each other to within fractions of a millimeter. To complicate matters further, we will receive conductors from 6 different sources, and each of these will have slightly different mechanical characteristics. It'll be the first time that a superconducting magnet of these dimensions and shape is manufactured with this technology. What's the next stage? At present, a number of winding trials are being carried out with conductors produced by the different suppliers. The objective is to define the bending parameters for all conductor types prior to the production phase. After these trials, a full prototype double pancake will be manufactured. This will then be the final step of qualification before we start the production of 70 double pancakes in order to manufacture the 10 winding packs.
The furnace is a massive oven that will heat treat the 70 double pancakes in groups of maximum 3 at a time to make them superconducting. It is 1.8 meters high, 10 meters wide and 16 meters long. When fully loaded, the heat-treated mass can reach 26 tons. How does the furnace operate? The heat treatment is carried out at different steps and temperatures reaching up to 650 degrees Celsius. The temperature homogeneity required is plus minus 5 degrees Celsius and the heating rate 5 degrees Celsius per hour. The heat treatment is carried out in controlled inner atmosphere, with maximum level of oxygen impurity being at 200 parts per million. One of the main challenges is the homogeneity required, plus minus 5 degrees Celsius, on such a large component. 6 fans are strategically placed at the rear end of the oven to guarantee a homogeneous heat treatment. What is the next stage? The oven has just been successfully commissioned, and the next step will be to heat treat 2 single turns of a double pancake, made with 2 types of European conductors. During the heat treatment, the conductor length changes slightly. This change in length will slightly modify the conductor trajectory. Therefore, it is important to measure this change for all 6 conductor types. In order to minimize the possibility of a mismatch, on each radial plate the grooves will be machined according to the inbuilt trajectory of each double pancake.
The function of the insertion tool is to insert the double pancake conductor inside the groove of the radial plate. This is a very critical operation because during the transfer, the deformation experienced by the conductor cannot exceed the value of 0.1%. Otherwise, the superconducting wire will get damaged, reducing the performance of the superconductor and, as a consequence, the performance of the TF coils. For this reason, the deformation of the conductor during the transfer has been studied and analyzed with computer analysis in order to make sure that the level of deformation of each part of the conductor during the operation will stay within the limits. In order to carry out the operation, the tooling will first slightly spread the two halves of the double pancake spiral, creating space between the two halves, then insert the radial plate in between, and finally deposit the conductor inside the radial plate grooves.